So I decided that I would go ahead and redo our little video of our lesson from this morning, simply because the other one was kind of long and hard to read because I'm still working on using a tablet. So I thought I would get it all for you on paper in handwriting and maybe make it a little shorter since we only did really discuss what functions are and their definitions. So um, again, for those of you who are watching it that didn't see it, definition of a function is a function from the set of a function we might call f, right? You'll see it as f of x, from a set A to a set B. Is a relation that assigns to each element x, right? X is like all of our everything in our set of A, or what our potential x's could be, what our potential inputs are. In the set of A, exactly one element or y in the set of B. Now, what that means is if I have, say, all these possible values of x, right? They fit into what is our set A, right? Anything x could be. And it's whatever we're calling our input, but more often than not, you're going to see things like f of x or g of x. And that just means that our input value is x. We're putting it, whatever we put in for x is going to map to something called our y, or set B. So this is our input. This is what we're putting in for, and this is our output when we form a relation. And a relation is just whatever action is happening to x. So if I have something that says, say, like 3x plus 2 equals y, or f of x, the relation is everything that we're doing to this input value, everything we're doing to x. And in this case, we're multiplying it times 3 and adding 2. And anything that we make x, anything we decide x should be, we're going to multiply times 3 and add 2. And that's what a relation is. It's what is the relationship between x and y? Well, we're going to take x, multiply it times 3, and add 2. And that is the relationship between x and y. Y is just what happens after we've multiplied by 3 and added 2. So when it's saying that I have this set A, I can have anything in this set of A. I could have A, B, C, D, right? And over here, I can have all these numbers, 10, 12, 14, 17. Doesn't matter what those numbers are. 92, 430. Doesn't matter what the numbers are that are in there. It's saying that for every element, everything that's in here, all the possible numbers, A, B, C, and D, for it to be a function, it can only map to one element over here. And it has to map to one element over here. right? A has to have a B. B doesn't have to have an A, but A has to have a B, right? So, and A has to have only one true value in B. So notice 92 and 430, they don't have anything mapped to it. There's nothing from X that is equaling that. That's okay. The only thing is everything from X has to have a match over in B. Everything in B does not have to have a match in A. This set A can only have one match. A cannot map to two different elements here. So if B was 10 and 12 as a solution, or 10 and negative 10, if that was in there, this wouldn't be a function, right? And so that's the first definition of a function, is you have to have these maps, right? And we're going to talk about the characteristics of functions. This is why I'm doing this in 2 lessons instead of 1, because this one will be all like the rules and regulations of functions, and then the next one will be solving them and evaluating functions. So then we have characteristics. Characteristics of functions. And if you were in class today, you will know there are 4. I'm going to get a better pen to write with. One, each element in A must be matched with an element in B. Two, I'm not going to go too slow because you can pause this anytime you want if you really care to get these down in your notes. Some elements of B may not be matched with an element in A, right? That's what we said. A has to have a B, but B does not have to have an A. Three, two or more elements in A can match with the same element in B. With the same. And 4, an element in A A, by the way, we call the domain, right? Cannot be matched with 2 elements in B. B, by the way, we call the range, right? When people ask you about range and domain, which you'll get a lot of in this course, the domain is all of our possible input values, whatever X can be, so to say. The range is all of our possible output values, right? Or y. And we can represent a function in 4 different ways. We can represent them verbally. We can represent them numerically, like with a table, graphically, and algebraically. And we're going to go over all of that in class on Thursday, and we're going to go over how to test for them, testing how to test for functions, whether it be algebraically, geometrically, numerically, or verbally. And we're going to run those tests and evaluate functions and stuff like that. And then you will have a WebAssign assignment attached to it. But since this is all I covered in class today, really, it was all these talking points. I will wait until Thursday to go any further. So that is all you get for today, a whole 11 minutes of me chatting about definitions. I'm also going to throw in a little video for you introducing functions. I'm not going to require it, but it might be a little bit more fun to watch and you get the same information out of it. So thanks, and I'll see you Thursday.